In this video, we're going to be going over inner products. An inner product space is a vector space with an additional structure called the inner product. Now, in inner product properties, we have the same 5 axioms as before as a vector space, except the one I really want to get into detail about is the non-negativity one, which has to be greater than or equal to 0. And what this is saying, we're used to seeing this as a vector, but in this instance, we're meaning a dot product. So we express this term like this. So the inner product is considered an inner product when the dot product of the same vector is greater than 0. The rest of the axioms like scalarity, commutativity, distributivity, factorability, we've all gone for it before on subspaces and vector spaces, so I don't think there's a need to review for those again. Now, for our example, we have an inner product, or we can consider this our vector space of -1, 1. Now, our integral inner product is going to be f, g, which is going to be our integral of f of x, g of x, dx between -1 and 1. Now, our function f of x and g of x are defined below. Here we have f of x is equal to x, and g of x is equal to x squared. I've described them here graphically. So what we have here is our function g of x, which is this parabola here, and we have this f of x, this straight red line here. They are continuous functions. But what we want to do is we want to find the magnitude of these two functions separately between -1 and 1. Now, another word for magnitude when describing our inner product is called a norm. We find our norm the same way we find our magnitude, which is, in this instance, we're going to find the norm of our function f, we must dot f with itself. Now, when we dot f with itself, we're also taking the integral inner product and integrating it from -1 to 1. So, cutting some math short, I've went ahead and done the math with f of x times f of x, which we obviously know is going to be x squared. So then when we integrate this, we're going to end up with the square root of 2/3. So the magnitude of this function here of f of x is the square root of 2/3. Now, we do the same thing for g of x. We multiply g of x times g of x, and in this instance, we get x to the 4th because x squared times x squared will give us x to the 4th. Now, when we integrate that from -1 to 1, we're going to end up with the square root of 2/5. Now, that gives us a total magnitude between here, -1, and 1. So we're keeping it enclosed within that vector space. So now, to find the distance between the both of these, we want to simply enough take our distance formula. But when we do our distance formula, we want to subtract the magnitudes from each other. But we don't necessarily take the numeric value that we got. We use our functions as a dot product. So if we move along here, we're going to take f of x minus g of x times f of x minus g of x. Now, when you work this out and multiply them together, we get x minus x squared, all under the root symbol, integrated from -1 to 1. Now, when we re-express this as a polynomial, we're just making this a little bit longer. We get x squared minus 2x cubed plus x to the 4th. Now, this is an easy integral to do here. When we end up integrating from -1 to 1, we end up getting 4 root 15 over 15, thus giving us our distance between our function f and g, which is going to be 4 root 15 over 15. Now, this concludes our video for inner product.